Okay, let us begin. Welcome everyone to the third international session of LoongArch Biweekly. And we have all the regular information as well as a special presentation from ptitSeb, the author of Box64 this week. Before we start, this meeting is organized. What is happening? Before we start, this meeting is organized by Loongson Hobbyist Community, a third-party organization unaffiliated with Loongson Technology or any of the companies, entities, and institutions mentioned in this document. Please limit discussion to open information only. We will not answer questions for products and designs currently under development or testing. Please refrain from making political statements or commentary for the duration of the meeting. And finally, opinions expressed in this meeting are strictly of the individual speakers. And how this meeting works, I'll probably stop showing this slide from the next time on. But most of the upstream updates come from the Chinese Biweekly, which took place last Sunday. We have also added additional updates from the past 3 days. If you would like to present, please contact me for editing permissions. My contact information are as follows. You're also welcome to just shout out in the group chats. Presentations will be in English, and we are joined by Anya, who will help with Russian translation or clarification when it's needed. We will also have a short Q&A segment after each section. If you would like to help in other languages, please let us know. And the meetings will be live streamed on YouTube. I believe it's currently live on YouTube at the Loongson Hobbyist Community, and it will be recorded and made available on YouTube, VK, and Bilibili. Okay, let's move on to upstream development, and to begin, we have GCC. GCC, and I'll leave this to Xi Royao.
So the first part will discuss something about the GNU compiler collection. The first part is still about the stack smashing protector that we've discussed in earlier meetings. The fix has been backported to the 14 and the 13 releases. The slide seems a little outdated. I just did the backport for 13 today. But unfortunately, the fix has caused a regression. We found the compiler would mistakenly generate 64-bit memory access instructions for 32-bit LoongArch. The fix is sent, but the upstream has responded that it seems not complete, and so a revision will be needed. The next item is about my GCC build boot. It found the master branch failed to bootstrap due to an internal compiler error in stage 3 or stage 2 if stage 1 has been configured with optimizations enabled. So I reported the issue to upstream. The upstream developer Andrea Pinsky reported AOSC is also affected. But it fails to bootstrap later at the comparison mismatch between stage 2 and stage 3. Andrea then found the issue is a misuse of the execute if set in hard register set macro. The macro requires the lifetime of the input register set to cover the entire loop, but an earlier refactor has passed a temporary object as the register set. The lifetime of the temporary object immediately ends even before the first iteration of the loop. So if optimization is enabled, the compiler will behave erratically. Andrea then fixed the issue, and I added a compile time check to make passing a temporary object as the register set to execute if set in a hard register set macro as a compile time error, so we don't repeat the same error again. Jeffrey Law fixed a scan assembler failure on the test case multiply const reduction point C due to the minor assembly difference introduced by an ext DCE. It means redundant sign or zero extension removal. It's an optimization path in GCC. It has been recently updated to cover more cases and then caused some minor assembly difference in that test case. It's not a real regression, just some minor differences of the assembly code, not so serious. Jia Jiechen reported that both GCC and LLVM don't generate the VFMax.S instruction for the AST/CE/NC rate test in the SPIC CPU 2026 test suite, actually benchmark suite. I found the VFMax.S is actually not suitable here because it has different semantics regarding the not a number values than the C code in the benchmark. Jia Jie then pointed out the VF compare point set set less than point S and V and V bit selection point V instruction pair should work for the benchmark code, but GCC still doesn't generate the instruction pair. If we perform the optimization manually, the throughput can be observed to increase from 37 million operations per second to 198 million operations per second. It seems GCC fails to perform the optimization automatically due to the threadful path. It's an optimization path. It has combined multiple fine nodes to a giant one, which cannot be recognized by the vectorizer. So the optimization is blocked. I've not performed a more detailed analysis for now. Xinmu proposed that the preserve non-calling convention should be implemented on LoongArch for optimizations in some special use cases. For example, the C-Python JIT compiler, especially combined with the master tail attribute. Rui Wang pointed out the calling convention has been already implemented for LLVM, but GCC still does not support it as at now. It seems nobody has really started to work on the GCC support yet.
So that's past 2 weeks LLVM progress. We have Lingrunze optimizing a bunch of LSX and LASX code generation. First, they have optimized the vector truncation operations using the V or XV pick EV instruction, along with a new selection DAG combine logic, which uses the XVF to int rz.w.d instruction to truncate floating point values to integers. For the usage of vpick EV instruction, the EV part means even, as the lower half of a wider value, when reinterpreted as elements of half the size, the LSB part obviously ends up in position 0 and 2, or 4, basically even positions. So using this to save some cycles. They also optimized the code generation for LASX, changing any extent to 0 extent, so as to prevent some vectors from being unnecessarily scalarized. It seems the code generation core will hand to the selection DAG pass with any extent values, meaning the higher half of the value might be either sign extended or 0 extended, but apparently the LASX pattern matching cannot handle the any extend all of the any extend cases yet. So there will be some unnecessary scalarization going on. Finally, a optimized conversion between unsigned integers and floating point values with dedicated LASX instructions. Then Wang Rui added new selection DAG combination logic for widening addition or subtraction operations with the corresponding H at W or H sub W instructions, along with the test case. Okay, the next page. And also, Wang Lei has fixed a possible ICE a crash where the logic handling FE extend operation for V2 F32 vectors might have a branch that ended up unimplemented. So this is basically a crash fix. Yeah. Okay, for Rust. Also, Wang Rui, he has migrated the vector load and store implementations from inline assembly blocks to using the intrinsic SIMD interface provided by the Rust compiler, refactored by him earlier, I think, in May. Okay, let's move on to Linux kernel. Okay, I'll also walk you through the Linux kernel changes. First, the platform support. Eric Biggers has removed the Loongson RNG driver because this driver was based on a framework that has no in-kernel users and has vulnerabilities, and it's not possible to make use of it from either in the user space or in the kernel. So in light of this, it may be a better option to simply resubmit it using a different framework. So the kernel and user space could actually make use of it. And Chenhua Cai has submitted QEMU firmware config support for LoongArch, the kernel side of it. Previously, QEMU obviously supported passing configuration in the device tree it assembles before starting up the virtual machine. And firmware config nodes and data are actually injected, but the kernel still has to be able to pull it out and present to the user space with the sysfs entries. And this part is historically scoped to each supporting architecture because on x86 and Spark and some other older architectures, the memory layout was non-standard. So for newer architectures like ARM64, RISC-V, or LoongArch, we would have to remember to add the architecture to the key config in order for it to be able to get built. Okay, so this part is also done. And George Guo has done key exec handover support for LoongArch. This patch set is in its second revision. And it's also ported the KLP build scaffold for LoongArch. KLP stands for kernel live patching. Then Jiang Haoran has implemented strict module RWX support for LoongArch for stricter memory access policies for modules. And Wang Hongliang has fixed maybe added the clock attribute for Loongson 2's I2C devices. Okay, next page. And finally, the last platform support change. LLVM has submitted the fifth revision of Loongson I2S support, the audio driver for Loongson 2 series. He has also submitted AOSC support for 2K2000, the Forever Pi, and DL2K300B boards. And for the KVM subsystem, Tweethall has submitted the second revision of paravirtualized KVM TLB flush support. Ma Qiang has submitted the fix for the CSR exchange instruction, where previously it was, I think, some edge cases were not implemented correctly. I think maybe some bad fall through or break for some select case, but I'm not sure. And Mobibo has submitted the third revision for configuring the maximum FPU feature set for the vCPU. It has also fixed a bug in the user space FPR interface, where the FPU only only had its FPU scalar state saved and restored instead of the full 256-bit vector state. And finally, Xu Yanfei has added a bound check for the IRQ chip array to prevent out-of-bounds accesses. And finally, for the BPF subsystem, Zhao Chengguang has allowed the K-pointer exchange operations to be inlined. Okay, next page. Finally, some smaller fixes. George Guo has fixed KLP, the live patching builds when configure kfans is enabled. And Wang Xuewen fixed a bug in the set direct map valid no flush function. This one's some deep down in the implementation. Some memory management subsystem edge cases. Finally, Marcus Alfred has simplified the show CPU info, namely some sequentially executed printf or putS statements that could get simplified. Okay, I think that's all.
Thank you, Wang Xurui. And next we move on to Box64, and we'll leave this to Liu Yang.
Hello, can you hear me?
Yes.
Okay, move to Box64 progress. So over the past 2 weeks, we have done a lot of the pre-releasing testing. So we fixed a number of things and we released the third preview of the current version. Okay, this is the right slides. So into the details. First, we removed the workaround that was forcibly using the emulated GNU-TLS functions, because we found that the hack is not needed anymore. So we also fixed several AVX-related issues, and then we enabled the AVX by default. We also fixed the WoW64 handling via the iReturn and corrected the absolute path resolution in the exec for Box32. We fixed the RDTSC emulation. This has been causing the Death Stranding to run extremely slow. We also fixed some error handling for the IO urine file descriptor in the mmap emulation, and we fixed the error handling of the signal function emulation. In addition, we added function wrappers for the pop wire. Finally, we fixed the bug in the code kitchen where it would be active even when the generic was disabled. So with that fixed, code kitchen is also we call it the Danakich. It's now enabled by default. Next slides, please. So moving on, we fixed the unexpected removal of the executable bits in the code pages coming from the native libraries page. So we use the dedicated pages for the bridges to jump from the guest world to the native world. We also added emulation for the PRCTL operation. It's called the Cisco User Dispatch. This operation has been used since the 1.11.5 to handle the certain raw Windows system calls. This is mainly used by some games to do DRM stuff. We know that the way one works is it intercepts at the API level, not at the system call level. So essentially, a raw syscall will go all the way to the Linux kernel, so it will cause issues because it's a Windows syscall, not a Linux syscall. So with this user dispatch thing, Linux kernel can forward the certain syscalls, including the ones he didn't know, to the user space. So one can use this mechanism to handle the raw syscalls. But as an emulator like Box64, we cannot use this PRCTL directly, of course. So we emulate its behavior by ourselves. Next, we also added the path interrupter wrapper for the Steam's press vessel container. This fixed some, I think it fixed some YMO64 in Steam. We allocated a dedicated register called V0 in the LoongArch backend to simplify the SSE and AVX instructions because many instructions need a zero vector register. So we just use a dedicated register for that. We fixed the LBT handling of the inline function to update the E flags. We also fixed the bug of the LBT status was not updating on jumps when it jumps to the next code block. We fixed some outcodes bug in the interpreter, and we also added some more wrappers for the LLVM and the Circle-Lite 3 to support the OpenWrt UI. Okay, next slide, please. Okay, now I'd like to introduce a new project called Lager. Lager is a utility that allows Box64 to run on the 16 kilobytes page size kernels. So essentially, it's a QMKVM launcher that generates and executes the startup commands automatically. It also acts as the init program, so it can set up the necessary guest environment to run the emulated programs. And you can find it on GitHub if you are interested. Okay, finally, a quick update on the Yuzu emulator. We have been working on a fork of the Nintendo Switch emulator called Eden to add the LoongArch support. And we have already two pull requests being merged. This winds up the LoongArch supporting the build system, and we also added the fundamental framework for the LoongArch dynamic recompiler. And we also implemented several simple IR operations. The next pull request is currently underway. So it implements more of the IR operations for LoongArch dynamic recompiler. Okay, that's all for me. Thank you.
Okay, thank you, Liu Yang. And now for other updates, let's move on to Yang Xinhui or Cyan.
First, let's move on to bug reports and feature requests. Xubing reported that PHP bench runs slowly on 3B6000, even when compared to Raspberry Pi 5, as previously reported by Phoronix. And the data showed there is a 40% less, it's 14% less than Raspberry Pi 500, which is a very strange result. So let's hope that will be fixed soon. And Xu Xiaowei, let's just call him Xu Xiaowei. Xu Xiaowei requested to add LoongArch support for the core plugins in this Container Network Interfaces project, CNI project. He also requested to add LoongArch support to Kubernetes release engineering tools. And the general contributions includes Alessandro Gatti added LoongArch support for MicroPython, a minimal Python interpreters for microcontrollers. That would be beneficial for, let's say, Loongson 2K300 or some even more microcontroller things. And A6D9A6M improved LoongArch support for the comics kernel, which is used to run some OS comp test runs. So this improvement adding support for automatic test runs and fixed the crash when bootting with large amount of RAM, possibly larger than 128 megabytes. So the OS comp stands for China's National College Students OS Development Competition. Next page, please. Ernest Pen resubmitted the patches for LoongArch SIMD optimizations in X265, a H.265/HEVC video encoder. The patches have now been merged after nearly 2 years in the pipeline. Wow, that's a long time. And Henrik Reidgård fixed a rendering issue with the game Need for Speed Carbon on the City, as reported in this issue 21.780. The patch also fixed other LoongArch specific issues. Li Hanlu fixed a PT load segment overlapping bug in LAT, which is the Longson's x86 architecture translator. The overlap occurs when trying to run x86 64 ELF binaries compiled for 4 kilobytes page sizes on a 16 kilobyte paged kernel. She also cleaned up the LATX tree, removing LoongArch target code. Qian Dongyan added LoongArch support for the UEFI GOP backend of the LVGL, an embedded graphics library with a conditional compilation branch. And here's the interesting thing. He published some pictures about the experimental GUI setup screen for his custom firmware. So are we finally going to see a fancy BIOS setup interface? That probably will happen soon. Wang Anjia fixed a build failure and a linker selection bug for REX, a compiler suite to build source-to-source transformation and analysis tools via Fortran. The build script for REX Docker image failed to choose LLVM's linker ld.lld as the linker for LoongArch. Instead, it chose ld.bfd, which comes with bin utils, which resulted in a 702.4 seconds link time. That's longer than 10 minutes when linking this librose.so. Linking time was greatly reduced to 10.7 seconds thanks to this change. Wow, that's a significant link time reduction. Solar Passerby finished the LoongArch port for RESP OS, an OS kernel based on our Core v3 as a operating system kernel tutorial, adding LoongArch specific linker script and a fix for entry address offset caused by frame header. TanaWell-D added support for GoOS Tamago, GoArch equals Loong64 to this Tamago Go project. This project is a bare metal runtime for secure and embedded applications written in Go, fully passing the test suite. The support was added on a phased approach as corresponded with the maintainers mentioned in the issue, which is a very comprehensive plan. It therefore did not include changes related to PIE executables and external binaries. Xu Xiaowei requested to add LoongArch support for etcd, a distributed key value storage system, along with a detailed list of pending changes. A maintainer, George Burkus, explained that all tests for etcd depend on Kubernetes test infrastructure, and this infrastructure does not yet support LoongArch. And Xu Xiaowei later added LoongArch support for core DNS, a core Kubernetes component for name resolution. Xu Xiaowei also added LoongArch specific CI build and release workflow to the core plugins for CNI, Container Network Interface.
And that should conclude the upstream updates for the past 2 weeks. And before we move on, do we have any questions?
Есть у кого-то вопросы?
Okay, let's move on. So now for distro and operating system updates, I'll start with AOSC's updates. So in the past 2 weeks, we have released core 13.2.1, which backported a fix for GCC, fixing a bug failure with Node.js 24.16.0 and newer the JSON versions, including projects using this library. Linux 7.0.11 is now available as a stable update. The update includes preliminary fixes for the mainline SMC voltage and frequency scaling driver. Full voltage frequency scaling on 6000 series CPUs and the 2K3000/3B6000M SoCs will be available when paired with the public beta firmware version 2026.05 coming this week or the next. There are also other notable updates. Firstly, with FFmpeg, which has been updated to 8.1.1 with support for Vulkan accelerated video decoding. The ROCm suite was also updated to the ROC 7.13, a technical preview release with comprehensive support for computational libraries. The ROS2 suite has also been updated to the latest versions as of June 2026. Also, we have, in more interesting news, we have also released LoongArch binaries for PowerShell 6.6.2. And finally, with security updates, and it's certainly interesting with now with LLVM assisted security auditing, we have seen an explosion in security updates. So in the past 2 weeks, we have addressed 137 security vulnerabilities and fixing, including 16 critical and 51 high severity vulnerabilities. This includes the fix for the HTTP 2-bomb denial service vulnerabilities found in the Apache HTTP server and Nginx. So if you're using AOSC on your servers, please also update your systems ASAP. And for OpenWrt, 3 weeks ago, Xingmu submitted a patch, a pull request to OpenWrt, which includes 3 kernel patches for their 6.12 kernel. to fix the Ethernet support for 2K3000 and 3B6000M. This pull request has now been merged and will be included in their next release. And now for Proxmox VE, we'll move on to Wu Kaiyang.
For Proxmox VE this week, I'm working on creating the installation media and found that the official installer program expects certain file structures and contents found in the official ISO image. However, the upstream did not publish the tools and scripts to build the official ISO images. So we consulted the upstream. We still haven't got the reply from them yet, but we'll continue. Proxmox VE customized kernel configuration for LoongArch and the corresponding Proxmox default kernel package is now available. You can now install the Proxmox flavor kernel to use the FS. And we'll continue to rebase our work on new updates from the upstream.
Okay, thank you. And now for Alt Linux. Let's move on to Ivan Melnikov. Oh, or no, sorry, Batayev.
No problem. I'm substituting Ivan second time in a row. He's working on build infrastructure and kernel build infrastructure updates. It's a very important task. Besides this, we concentrated on our two major products, Alt Server, which passed QA verification, and we took several architecture-specific bugs to work. And Alt Workstation is finished development verification internal, and we're ready to pass it to quality assurance. That's it for our biweekly activities.
Okay, thank you. And before we move on to community news and events, do we have any questions?
Есть у кого-то вопросы?
Okay, we'll move on. So for roaming Loongson, it's basically our program to lend our LoongArch devices or remote servers to developers in need. So if they need, any of you would find yourself needing latest LoongArch hardware or more computational performance, you can come to us and apply for devices. So we have 2 new boards which are now available for the projects, including 8-core and 16-core 3B6000 motherboards, and we have 10 of each available. So if you would like to access the boards either remotely or shipped out, it's not only remote access. If you need the board with you, you can also apply for it at the link below. And I'm assuming there's going to be no question about this, so we'll move on to ptitSeb's special presentation on Box64.
Okay, so I will be talking about gaming on LoongArch with Box64. And basically, you can go next. Sorry. So what can you expect to run with Box64? What do you need to run stuff? And then I will more enter into detail at what is Box64 and how does it work. So next. Let's begin with, does it run Crysis? Because it's important, right? And yes, actually, it does run Crysis, and it even ran the Crysis remaster from Steam. And next, please. Actually, it can run a lot of stuff. So you can run AAA game, current AAA games. You can run launchers, Steam, Battle.net, Ubisoft. There is a lot of stuff that runs. You can have in box86.org an app, a small app with a few examples of stuff that runs. If you have more examples of game that run, you can add also a compatibility item. It's on GitHub. Basically, you just create a new issue and you said, okay, this game with a screenshot runs on my machine, and it will appear on this application. So I haven't checked how many LoongArch games are already in the compatibility list, but there are at least 3 pages, something like that. So that, I don't know, 50, more than that. So it's still a work in progress, but there are much more games that run than the compatibility list show, but it's just to give you an example. Next, please. So to run all this game, what do you need? Next, please. So let's talk first about the hardware. And of course, you need a Loongson CPU, a 6000 series. Any one of the 6000 series that is for desktop will do, or the Irtish C6 series will also work. So you need a good CPU, but any CPU will work. I mean, the 5000 can work on Box64, but they are not fast enough to really play AAA game. But if you start with a 3A 6000, you can do stuff. It's better to have a 3B 6000, but even the 3A 6000 you can play. Of course, if you want to play, you need a good GPU. So don't go cheap on the GPU, because it's an important part. And for compatibility reasons, for now, I would advise to stick to AMD chipset. I don't know, maybe I think I've seen some Intel chipset more or less running, but it's very experimental. So better stick to good AMD stuff with a lot of memory. Also, the machine needs a lot of memory. 8 gigs is a minimum, because we are emulating stuff here, and emulation needs memory. So even if a game should run on 4 gigs on a regular PC, when you emulate stuff, you need to double the memory, at least add some memory. So 8 is a minimum, and 16 is better. And the storage, well, games are huge. I mean, you can find games that are more than 100 gigs of memory, so of storage. So of course you need big storage. Next, please. Now, what about the software? Well, one important thing is the 4 kilobyte of page size kernel. This is highly recommended. Of course, there are some work to launch games and stuff on 16 kilobyte page size, like with Lager, for example. But for the best experience, and if you want to run a latest AAA game, you need a 4K. That's it. Also, you need the regular Linux component, like sound driver, ALSA or Pulse Audio for Box64, X11 Wayland, and X Wayland is probably useful, and latest OpenGL, latest Vulkan. If you want to run a Windows game, Vulkan is a must-have. And then you will need Wine or Steam or some launcher like Heroic Launcher or stuff like that. And of course, the latest Box64 built with Box32 for 32-bit support, and BinFMT integration. So it magically launched stuff by just double-clicking. So for all this, I would highly recommend to use AOSC OS because all the kernel comes with a 4K version of it, and everything is prepackaged in AOSC. You can find Box64, Wine, Steam, Heroic Launcher, so you don't need to build stuff or install or whatever. You can just install the stuff, and it's maintained by the OS. So if you just want to play, AOSC for now is the way to go. And next, that's it for the hardware and software. Now, let's talk about Box64. Next, please. So before talking about Box64, I will talk about Box86 because it's the father of Box64. And Box86 was designed to run on a very underpowered portable machine that is the Open Pandora, as you can see in the picture. It's a clamshell microcomputer, and it's based with an ARM CPU, and it's not a lot of power, not a lot of memory, not a lot of storage, because the storage is SD cards. So it's quite a weak machine. But yet the objective was to create an emulator that could run some stuff from the 2000, stuff like that, directly on the machine. And because it's a Linux computer with a keyboard, as you can see, my objective also was to be able to develop and code on the machine itself. So Box86 was started directly on the Pandora. And if you know me online, if you take a look at my avatar on GitHub or whatever, you will notice that it's actually a Pandora. My avatar is a Pandora. It's a black model, but it's basically this. So the point of Box86 as a design standpoint was very light. Use as little dependency as possible so it can be coded directly on the machine. Do not emulate stuff if we can avoid to emulate because the machine is weak. And do not use a rootfs because the storage is limited because it's a SD card. So try to not include a rootfs like in every other emulator. Next, please. So after Box86 was running and working, I had to create a new product, Box64, to go to the 64-bit world. So Box86 basically is able to run any 32-bit x86 program on a 32-bit ARM machine. And Box64 was developed to run 64-bit x86 program on a 64-bit ARM machine. That was the initial development. And after a while, because the 32-bit OS and CPU were end of life, basically, I started to think about Box32 that will allow to run 32-bit x86 apps on 64-bit OS. At first, I created Box32 as a separate product and to check if it was possible. So it was my proof of concept. And after a while, I just integrated all the changes of Box32 inside Box64 to avoid too much duplicated code and too much duplicated maintenance. So now Box32 is just a part of Box64. But initially, it was separate. Next, please. So this is just a quick, this is a timeline, but I will not detail all the points because it will be boring. Just a basic date. So I started working, I created Box86 idea in 2018, and I needed almost 1 year to have the first version that was actually loading a game and running a game. And this is the first picture on the top. This is Airline Ticon Deluxe that is working on the Pandora. And this version was the first game, basically the first, it's not a AAA game, but it's a game. It's a commercial game, and it was running at a decent speed on the Pandora, and it was only with an interpreter. There was no DNAREC at this time. So basically that was, the proof of concept was validated at this point. Yes, all the stuff that would make Box86 and Box64 is working, the wrapping, the interpretation, and everything. So after that, okay, I added the almost 1 year again more. There was the DNAREC that was implemented. So now it was even faster. And Box86 will continue a bit. Box64 will then be not a fork, but a copy of Box86, and it was created late 2020. And because I used all the experience in Box86, Box64 was much, much faster to get stable. So 4 months later, I had some build that was running again, like World of Goo, that is the second picture. It's one of the first game I ran with Box64. And yeah, So 4 months later, after I started Box64, I had a version that was running with Dynarec, and I could really build and make things more stable. After that, okay, Vulkan support was added. Box86 plus Box64 were running Linux Team at some point. Then there was the RISC-V Dynarec that was added. Then LoongArch Dynarec was added. And we had AVX and AVX2 because it was beginning to be mandatory in 2024. The more and more games needed AVX. And then we integrated Box32 to remove the needs of 32-bit OS. And then it continued until this point at always trying to be able to run Steam, to run the latest game, to run DRM and everything. Yeah. Super Hexagon was one of the first World of Goo simple game that use OpenGL and that are easy to debug. Because if you start with, I don't know, Need for Speed Heat as your first game, you will fail for sure. Anyway, you can look at the timeline later if you want. Next, please. So now let's have a quick look at how Box64 actually works. Next. So there are 3 big blocks that are all interconnected in Box64. There is the ELF loader, there is the librarian, and the emulator. So the ELF loader is responsible for loading ELF file that are the Linux binaries. So basically, it has to read the file, decode the file, put it in memory. The librarian is handling all the libraries. So because usually ELF are not just a file, they are using a lot of library interconnected. And the emulator is, emulator, but there are 2 parts in the emulator. There is an interpreter that is written in pure C and is working on every architecture. And there is a Dynarec that is only for ARM, LoongArch, and RISC-V. And that is much faster than the interpreter, but is just for a few architecture. Next. So the ELF loader, when you launch a program with Box64, even if you just click at a program, if you click in a program, it will still launch Box64. The point is to load the ELF and do what Linux is doing, but we do not use the Linux code to load because we need to inject a few stuff here and there. So everything that Linux is doing, Box is also doing it with its own code. So we load the ELF header, we load the program header table, the section header table, and we load everything in memory, extract the dependencies, ask librarian to load the dependencies, and get the symbols and resolve. Ask the librarian for the symbols to resolve. And when everything is done, emulate the code. So the ELF loader is the entry point. Basically, it's what loads the program in memory. Next, please. The librarian is handling libraries. So what it does is fairly simple. It's you ask the librarian, okay, load me this library. And the first thing is this library already loaded? Because if it's already loaded, it's easy because it's already done. And if it's not done, then we have to see, okay, is it a library that can be wrapped or is it a library that is native? And the wrapping of the library is something quite unique to Box64. And it means that instead of using full emulation for a library like, for example, SDL2, we don't emulate SDL2, and we will load the native version of SDL2 and just wrap the API calls so the native library is used. And at no point we will use any emulation for SDL2. That means, first, it's easier to integrate Box64 in the system because many libraries are just the native version. You don't need the rootfs, as I explained with Box86. And the second point is that, well, it's faster because the less you emulate, the faster you go. And the magic is in the librarian. This is where the wrap library will be used instead of the emulation library. It's at this point where the check is done. And one thing to note here is that if a native library cannot be loaded for some reason, because, I don't know, maybe the library is not here, then Box64 will try to use the emulated library instead. So even if you don't have, I don't know, some X11 obscure X11 component, if you put the x86 version of it, it will be used instead. And so the wrap is optional, but not for all the libraries. Because Box86 is very reliant on the wrapping, there are some libraries that cannot be emulated. And this is mostly libc, libm, pthread, this kind of library. This kind of library needs to be wrapped, but they are always part of the system anyway, so that should not be a big issue. But just to be clear, the wrapping is the biggest strength of Box64, but it's also its biggest weakness, because I can have another discussion about that at a later time anyway. Okay, next please. And now the emulator. So emulator, as I told, is in two parts. There is the Dynarec and the interpreter. So the Dynarec is a simple, between quote, conversion from one OP code to one native code, or one or many native code. And so the Dynarec will work in a block, and its first task will be to determine how big the block will be to convert, and then convert this block as a chain of OP code. And the objective of this Dynarec is to be as close as possible to a 1-1 conversion, meaning one x86 OP code translate to one LoongArch OP code. And of course, it's not always possible, but that's the objective. And just a side note, if something goes wrong with the Dynarec and some OP code, for example, is not supported or something like that, the execution will fall back to the interpreter. And this is a good mechanism that allows a step-by-step implementation of a Dynarec for a new architecture, for example. But it also allows some interesting stuff like a dual run comparison between interpreter and Dynarec to compare to make sure that everything is correct in the Dynarec, especially. In the right of the screen, you can see a dump of the Dynarec on LoongArch. So basically, the orange line are the x86 code that is being converted. The yellow line is some metadata about the Dynarec, and the white is how many code is the LoongArch OP code that are outputted by the Dynarec. And I have highlighted 4 interesting points, but there are many more, and it's just to highlight a few of the tricks that the Dynarec on LoongArch is doing. So, for example, the first line, we can see here, it's a simple, we have an OP code that is AND RCX, which is a logic comparison, which should generate a shit ton of flags, but will not in this case because none of the flags are used. So in this line, we can see that the one OP code x86 is actually converted to just one OP code on LoongArch, and no flag will be computed, nothing. It's very simple. We are on the 1-1 OP code, and you can see there are a few OP code like that with just 1-1 OP code. The other interesting point is, so the second point is the fuse of two opcode. In this line, you have the line before that is a compare, and then you have a conditional jump just after that. And if we do a 1-1, just a simple conversion, we will generate some flag at the compare and then consume the flag at the conditional jump. But here, because the condition is just using this conditional flag and they are close one to the other, we can fuse the condition and the jump into a single conditional jump, the back opcode in LoongArch. So we actually reduce two instructions to a simple one, because the second instruction is an up, though, so it's not really an instruction, but it's here for consistency. And again, I can explain that at some other point. The third interesting point is x86 is a very complex set of opcode, and the ESA allows to do arithmetics operation on memory location, which is not possible on most RISC architecture. You have to load the memory, do your arithmetic, and then store the memory. So in here, we have a logical operation between a register and a memory. So we have no choice than to do two operations. The first one to load the memory, and the second one to actually do the logic operation. There is no other way in this case. And the fourth point is just to make to show you that a block, as defined in the dynamic, is as big as possible, because everything inside the block can be optimized and fine-tuned. Everything that is outside the block is unknown, so you cannot optimize stuff that is outside of one block. You cannot make any assumption of everything that is outside the block. But inside the block, you can do assumption, and you can actually optimize, remove flags, and do stuff. That's why blocks are larger than just, they are not breaking at the first jump. And in here, you have an unconditional jump, and yet the block will continue. And because there is a analysis that shows that, yeah, we can continue the block, make it bigger. And so we have jumps that are inside the block that are conditional or unconditional. It can happen. And that makes the dynamic more efficient and generate more optimized code, because the bigger the block usually, and the better the optimization. And yeah, that was just 4 little highlights on this small piece of code that comes from Factorio, if I remember correctly. And I just wanted to show you what is the result of the jump of the dynamic. And just a side note, this dump that you can see, you can generate that with Box64, whatever you want. It's not a special tool. It's integrated inside Box. You just need a few set of command line operation or some settings in the settings file, and you have a dump generated for you. So it's not, you don't need any specific tool to generate that. Just command line, and that's it. You can generate that for every program. And yeah, that's it for my presentation.
Okay, thank you, ptitSeb. And we will now move on to the final Q&A segment. Do we have any questions for either all the speakers before us or for ptitSeb? And well, I have one question. So, ptitSeb, how would you pronounce your name?
Yeah, sorry. Yeah, it's a very French name. So its name, it's you will do ptitSeb, and basically yeah, it's ptitSeb, and that means small Sebastian, basically. And it's French. It's ptitSeb.
Understood.
It's little Sebastian.
Understood. Thank you. Okay. Does anyone else have questions?
I have one question for Box64. So how do you decide a code block must be terminated so you can move on to another block, either translating or loading it?
So the entry point of the block is the x86 address that wants to be executed. So the entry is easy, right? How do you end the block? So it will be done by a first iteration. We'll go through every opcode and try to continue. So if the opcode is known and is not a jump or a call or something like that, it will just continue. Okay, so every regular opcode, not a problem. If you have a jump that is a conditional jump, we just continue also. If it's a call or an unconditional jump, so something that should break the block, there are some parameters to say, oh, can we try to continue anyway after this jump? Like we check back on the previous conditional jump that, or non-conditional or non-conditional jump that was before, and we check if there is a jump that land after this potential break, if you see what I mean. And yes, there is and if there is a jump that lands there, we continue. If there is no jump, if there is nothing, we just end. Is that clear? You see what I mean?
Yeah, I understand. Yeah, thank you. So it just analyzes the simplest case is just one function without any jump, and the more complicated one is functions with local jumps, and then functions with contains another call, yeah. and you have to analyze after the call. After the call, the emulator can or cannot jump back to the current function.
Yeah, there is actually there is so Box64 has a lot of parameter, so you can fine tune execution and stuff. And for example, there is an optimization that is called call rate optimization. And for example, if you call not a native function, okay, yeah, I have to explain many things. When we see the call function, there are many cases that can happen. We analyze the call, how the call is done. There are, for example, the two simplest or the two most common call are call to a native function in some call to a function in a library, or call to an internal function in the code itself. If it's a call in the library, we analyze if it's by any chance a native function that is wrapped as a, I don't know, for example, some OpenGL drawing code. If it's a native function and if it fits certain settings, we will generate a quick prefix to actually inline the call to this native function directly in the generated code. And that will be very fast with minimum register swapping and everything, a very fast call to the native function. And it's actually very efficient in that way. But if the call is something generic, and if we have the call rate enabled, we will generate the call, and we know that the call will return. So we also we continue to generate the block because we know the call will return. That's for the call. There are a few other cases, but it's not relevant for this explanation.
Thanks for your explanation.
So I have a question from a friend near me, Cyril.
So I want to ask something about the thing called ledger. It's basically running 4 kilobyte page kernel in a virtual machine. But how do you provide the GPU driver in the virtual machine?
Oh, that's
Okay,
so
and
that's
I think
for
that's a
you.
question for Liu Yang.
Yeah.
Sorry, for me?
Yeah. How
Can
do
you
you
repeat
provide?
the
How
question?
do you provide
Yeah,
GPU?
Yeah.
Cyril was
How do you provide
asking,
GPU inside
yeah,
Lager?
how do you use GPU inside Lager?
A GPU, we use something called the what's its name? It's called the native context.
Oh, it's
So
CRG or something like that, right?
basically it uses the host method to do the graphics. It forwards all the OpenGL and working codes to the host. That's the fastest of it. But I I can say it's stable or even usable because when I run some especially when I run some big games like some AAA games, it's just freeze the whole system. But when you run some small games, it's really fast and nice to use. Another solution is the Zinc. Uh, it's provided by the WordGL renderer. I think that's the name. So basically, it translates all the OpenGL and the working codes in the guest into working codes to the host. So there is a translation layer in between. So the performance is not good in that case. But it can run some big games like the Frozen uh the Forza Horizon 4. But it can only achieve 50% of the 4K bit kernel's native, uh, and it requires much more memory than the native 4K kernels. Also, it requires some private patches to fix a bug in the WordGL renderer. So I wouldn't call it a good solution. So it's the situation is a bit awkward now. Um, I think I would prefer to try to figure out why the native context is not working on large workloads. I think the Zinc is not very promising, even if there is no bugs, because the performance is quite bad. Okay, does that answer the question?
We do have a question on Bilibili called from Jeremy 2009. When will A64 or the 3B6600 will be delivered? So there are some public information from Huiwu himself. We believe that the chips are currently being taped out and they should come back in October, which means that given a season or little more, we should start to see earlier development boards or motherboards coming early next year. I think that's about the timeline we're expecting. Okay, if not, the next meeting will be on June the 25th at the same time. So it will be 2 Thursdays from this week. We will see you then, and thank you everyone for joining us. And to the left are the QR codes to our Telegram group and the Discord server. So if you're interested in joining the day-to-day chat, please do so. And thank you everyone again for joining us, and we'll see you in 2 weeks.